Hello, welcome to Not for Exam, and I am your host Sujit, and we are going to discuss relation between torque and angular momentum. We already discussed that angular momentum about a point O is given as LO vector is equal to LCM vector plus R vector cross P vector. Here LO vector is net angular momentum of a system of particles about point O, that will be equal to sigma of Ri vector cross Mi into Vi vector. Therefore dLO vector by dt is equal to sigma dRi vector by dt cross Mi into Vi vector plus sigma Ri vector cross Mi into dy vector by dt. First term is 0 and the second term will be sigma Ri vector cross Fi vector, that will be equal to net torque about point O. Therefore dLO vector by dt is equal to tau O vector, that means rate of change of angular momentum about point O is equal to torque about point O. Now net angular momentum of a system of particles about its center of mass is sigma RICM vector cross Mi into VICM vector, and differentiating it with respect to time, we get dLCM vector by dt is equal to sigma dRICM vector by dt cross Mi into VICM vector plus sigma RICM vector cross Mi into dVICM vector by dt, or dLCM vector by dt is equal to sigma VICM vector cross Mi into VICM vector plus sigma RICM vector cross Mi into AICM vector. Here first term is 0 and therefore dLCM vector by dt is equal to sigma RICM vector cross FICM vector, that is torque about center of mass. From here dLCM vector by dt is equal to tau CM vector, that means rate of change of angular momentum about center of mass is equal to torque about center of mass. Also if we differentiate the relation LO vector LCM vector plus R vector cross P vector, then we get dLO vector by dt is equal to dLCM vector by dt plus R vector cross dP vector by dt, and that will be tau vector is equal to tau CM vector plus R vector cross F external vector. Here R vector cross P vector is angular momentum of center of mass and R vector cross F external vector is the torque of net force on center of mass. If center of mass is at rest, that is V vector is equal to 0, then LO vector is equal to LCM vector, that is angular momentum about point O. That means angular momentum about point O is same as angular momentum about center of mass if center of mass is at rest. Also from here we can understand that in this case net angular momentum will be same about each point and is equal to angular momentum with respect to center of mass. Here angular momentum about center of mass is also called internal angular momentum of the system. Also if external force is 0, then by the relation tau vector is equal to tau CM vector plus R vector cross F external vector, tau vector will be equal to tau CM vector in this case. So torque about any point is torque about any other point, and all these equal to torque about center of mass in this case, and therefore torque about any point will be same if F external force is 0. Here torque about center of mass tau CM vector is also called internal torque of the system. Thanks for watching Not for Exam, and we will see you next time.